All right, so this section or this video, we're going to look at linear equations in two variables. We're going to talk about slope, finding equation of lines. Going to look at graphing by using the y-intercept and the slope, parallel and perpendicular lines, and we'll look at a couple application problems. All right, so let's go ahead and get started. So first, let's look at slope. So the slope of the line through 2 points, x1, y1, and x2, y2, where x1 and x2 are not equal, the slope, okay, this is your slope here. And we usually denote the slope with the letter m, okay, is y2 minus y1 over x2 minus x1. So let's look and see what that looks graphically. So if we have 2 points, okay, and those 2 points are connected with a line. So we've got the point here, we've got x1, y1. We got the point here, x2, y2. All right. So if we drop this down, I'll tell you what, let's do that in a different color. We drop this down. This would be x2. This would be x1. This would be y1. And this would be y2. All right. So this right here, this distance from here to here, let's use a different color. From there to there, that is y2, from here to here to this point. That's y2 minus y1. That is the rise. And then this distance from here to here, that's x2 minus x1, and that is the run. Okay? So slope, it's the change in the y values divided by the change in the x values. Another way we can look at it is rise over run. Okay? And we'll get more into that as we go through the lesson. We'll look at rise over run when we're graphing. That comes in handy. But first, let's get started by finding the slope of a line. So to find the slope of a line passing through 2 points, okay? Find the slope of the line passing through the 2 points. So we've got 3 problems here. So the first one, I've got 2 points here. So I'm going to label this x1, y1, and x2, y2. Now, let me ask you this, and I want you to think about it. Should I have labeled this one x2, y2, and this one x1, y1? Should it be labeled like this down here in red or this up here in white? It doesn't matter. You can label them either way. It makes no difference. So what I'm going to do, I'm just going to label them x1, y1, and x2, y2. Now what does make a difference is if you call this one x1, this has to be y1. In other words, you can't call this x1 and this one over here y1. You can see in our formula, x1 and y1 have to be together, and x2 and y2 have to be together. Okay? Now, we've got a formula here that we got to know. Okay, so we've got to know the formula for a slope, this right here. So if you've watched my previous videos, whenever you have a formula, write it down every time you use it. That's going to help you remember it better. So I've got the slope is y2 minus y1 over x2 minus x1. So now we just plug them in. So y2, that's 2 minus y1, which is 4, over x2, which is negative 1, minus x1, which is negative 3. And so this is going to be negative 2 over, that's going to be negative 2 plus 3, which is 2, And so that's going to give us -1. All right. All right, so I hope that made sense. There's your slope. Okay. Let's look at the next one. So that's y2 minus y1 over x2 minus x1. So let's plug these in. So this is x1, y1. This is x2, y2. So I've got x2, that's 7 minus, y2, which is 7, minus y1, which is 7, over x2, which is 5, minus x1, which is -3. And so that's 0 over 8, which is 0. And so there's your slope. Okay. Now what about this one? Remember, write the formula down every time you use it. That's going to help you remember it. So I've got y2, which is 8, minus y1, which is 5, over x2 minus x1. And so that's going to give me 3 over 0. Now remember, when you have 0 in the denominator of a fraction, that is undefined. And so there's your slope. Now, let me go back and say a little bit more about part B and C. Okay? So with the slope of 0, this is a horizontal line. Okay? And this is a vertical line. All right? So if the slope is 0, that's a horizontal line. The slope is undefined, that is a vertical line. All right? So let's keep going. So now that we know how to find the slope, let's look at the different forms for the equation of a line. So it says here we have Pointslope Form. It says the equation of the line through x1, y1 with slope m is y minus y1 equals m times x minus x1. So here's another formula you've got to know. Okay, the Pointslope Form. So far we've got the formula for the slope of a line if we're given 2 points, and now we got Pointslope Form. So what they're wanting us to do here is find the equation of the line through the point -2, 3, and it has slope 1/2. All right. So let's go back and read this again. It says, find the equation of the line, and right there you stop. Okay? Right there you stop. So when it tells you, when you read, find the equation of the line or write the equation of the line, the first thing to pop in your head is, I need slope and a point on the line. That's the 2 things you've got to have. You got to have the slope of the line, and you got to have a point on the line. All right? So if we look at this, do we have a slope? Yeah, we got the slope right here. Do we have a point on the line? We have a point on the line. So we have everything we need. So let's write our formula down. So that's going to be y minus y1 equals m times x minus x1. And here the 1/2, that's m. And then I have x1, y1 for my point. See? With slope m and passing through x1, y1. See? Passing through x1, y1 with slope m. And so all we do is we plug this in. And so we get y minus 3 equals 1/2 times x. See, I plugged the 3 in for y1, and now the -2 in plus 2. All right. So I hope everybody understands how I got the plus 2. Look at this part here. I plugged it in. X minus negative 2, right? Plug the negative 2 in for x1, so that's x minus negative 2. The two minuses make a plus. And then we just solve this thing for y. So I'm going to distribute the 1/2, so y minus 3 equals 1/2 x plus 1. And then I'm going to add 3 to both sides. And so I get y equals 1/2 x plus 4. And there's your answer. Okay. All right. Let's take a look at another example. Find the equation of the line. Okay, so remember what we just talked about. Find the equation of a line. First thing you think of, I need the slope and I need a point on the line. All right. So let me ask you, do they give us a point? Yeah, they actually give us 2 points, don't they? Do they give us the slope of the line? No, they don't give us the slope of the line. But look, we've got 2 points, don't we? And if we have 2 points, we can find the equation. We can find the slope of the line. Okay, we just did that in these 3 examples here. So let's find the slope. Okay, so first the slope, m equals y2 minus y1 over x2 minus x1. So that's going to be 3 minus 4, y2 minus y1 over x2 minus x1. And so that's going to be negative 1 over 3. So there's the slope of my line. Okay, slope of my line is negative 1/3. Now I have the slope and I have a point on the line. Okay, so now we can do y. Let's do it over here. We can do y minus y1 equals m times x minus x1. All right. Now, I've got my slope, m, right here. But which point do I use? Which one is x1, y1? Well, it doesn't matter which point you use. You can use either one. What I would recommend, use the one that's easiest. Okay, use the easiest one. So, in this one, it doesn't matter. The numbers are both sets of points. The numbers are small. Usually what I tell you, if you've got 2 points, use the one with the smaller numbers. They're both the same. Negative 1, 4, and then 2, 3, not much difference. So the next thing I would do is I would probably just use this one right here because both numbers are positive. Okay, if you'd rather use this point, that's fine. So let's plug it in. So y minus 3. Let me change colors back. So y minus 3 equals m, which is negative 1/3, times x minus the 2. And then I distribute the negative 1/3. So y minus 3 is negative 1/3 x plus 2/3. Add 3 to both sides. And so I get y equals negative 1/3 x. And that is going to be what? Plus 11 over 3. And this would be your answer. So a lot of times I get the question, how did you get 11/3? I just did the 2/3 plus 3. So if you do 2/3 plus 3, that's 3 over 1. You get a common denominator of 3, that's 2, and that would be 9. So there's your 11/3. All right. All right, let's look at this one. So I've got 2, 5, negative 6, 5. Same thing here. Gotta have the slope, gotta have a point on the line. They give us 2 points on the line. They don't give us the slope, but just like in the last problem, we know how to find the slope. y2 minus y1 over x2 minus x1. So that's going to be 5 minus 5 over negative 6 minus 2. And that's going to give us 0 over negative 8, which is 0. All right, so we got the slope. So we can plug this all in to our y minus y1 equals m times x minus x1. And if you do that, that's fine and everything. You'll get the correct answer. But let me show you something here. Okay, we don't need this on this problem. So if you go and you find the slope, you're given 2 points like this, and you go to find the slope. If you get a slope of 0 or undefined, you can work the problem without this. Okay, and let me show you how. All right, so we got a slope of 0. If you remember earlier, I told you if you have a slope of 0, that is a horizontal line. If you have a horizontal line, the equation is y equals. That's the equation of a horizontal line. Y equals. And what is y? It's 5. And so there's the equation of your line. All right. And I mean, we could even go further and graph this thing. So y equals 5, if we graph it, that's a horizontal line passing through where y equals 5. And there's your graph. All right, let's work the next one. So we've got 2 points. Let's find the slope. So m, that's y2 minus y1 over x2 minus x1. So that's going to be 9 minus negative 1 over 3 minus 3. So that's going to be what? 10 over 0, which this is undefined. So there's the slope of your line. All right. So we don't need that point-slope form. Okay. The slope's undefined. If you have a slope that's undefined, the equation of your line is x equal. What's x? It's 3. So it's x equal 3. That's the equation of your line. And we could go over here and graph it. X equals a number, x equal 3. That's a vertical line passing through where x is equal to 3. And that would be the graph of that line. All right. So see, this is not that bad, okay? Finding the equation of a line, the only thing you have to remember is I need a point and I need the slope. That's the 2 things you need to find the equation of a line. All right? And that's what's going to be different in these problems where they're asking you to find the equation of a line. See, in the first example we worked, they said, here's the slope and here's a point. In the next examples that we worked, they said, here's 2 points. Well, we had to find the slope. And we're going to do some problems later where they're going to tell us that our line is parallel or perpendicular. And we'll have to find the slope. Okay? That's what's going to be different in the problems. But with all of them, when we get a slope that is not 0 or not undefined, you're going to have to use this in all of them. The thing that's going to be different is how we find the slope. Okay? And look, if you take calculus or trig or pre-calculus or something like that, you'll end up finding the equation of a line in those classes also. And what's going to differentiate those problems from these is the way you find the slope. Okay? All right, so let's look at this. We've got another form. So the first form we had was slope-intercept form. Was point-slope form. And now we have slope-intercept form. So the equation of the line with slope m and y-intercept 0b is y equals mx plus b. So here's another form you have. This is called slope-intercept form. So for slope-intercept form, all you need is the slope and the y-intercept. Now remember, the y-intercept, I went over this in a previous video. See, if you have a line like this, that's your y-intercept where it crosses the y-axis. And you can see the coordinates of the point. See your x-coordinate, did we move left or right any? No. Your x-coordinate's 0, and then you'll have some number here for your y-coordinate. Okay? And so that right there, that number you get for y, that's your y-intercept. So let's go ahead. They want us to identify the slope and the y-intercept. Okay, well, how do we do that? Well, in this one, they give us 3x minus 5y equals 10, don't they? Well, they give us the equation of a line, and they want us to find the slope and the y-intercept. So it looks like from this up here, all I need to do is solve for y. And then the number in front of x is my slope, and then this number right here is my y-intercept. So, okay, so let's solve. So subtract 3x. So I get negative 5. So I get negative 5y equals negative 3x plus 10. And then I'm going to divide everything by negative 5. And so I'm going to get y equals 3/5 x minus 2. All right. So now you can see I have it in this form here. Mx plus b. Mx and the b. It's a minus, but that's fine. So my slope is 3/5. That's the number in front of x. Now, one of the things that students always do is they'll write that as the slope. That is not the slope. The slope is m, the number in front of x. So don't include that x. And then the y-intercept is 0b, and in this case, b is negative 2. Okay, I know the formula says y equals mx plus b, but this can be written as 3/5 x plus a negative 2, right? See, there's your plus and there's the negative, so negative 2. All right, so what about this one? Well, let's solve it for y. So I've got y plus 1 is equal to 1/2 x plus 3/2. And then I'm going to subtract 1 to both sides. So y equals 1/2 x. What is that? Plus 1/2. 3/2 minus 2/2 is 1/2. And so my slope is 1/2. My y-intercept is 0b, and b is 1/2. There's my slope and y-intercept. There's the slope and y-intercept for that one. All right. All right, now let's look at graphing. All right, so if you've been watching these videos in the playlist and you've gone through them, then in one of the videos you saw that we graphed some linear equations, some linear functions. And the way we graphed them was by finding the x and y intercept. And that's an acceptable way of graphing these things. And another way of graphing them is making an XY table. I'm sure you remember that. You make an XY table, right? And you can pick whatever values you want for X, plug them in, and calculate your Y value and plot the points. That's another way to do it. Well, in this video, we're going to look at graphing these things using the slope and the y-intercept. And let me say, graphing these things, if you want to see some videos with more detail, not so much more detail on graphing with the slope and y-intercept, but the 3 different ways to graph linear functions, just go search my channel and type in graphing linear functions, and I think there's a video graphing linear functions using tables, and then one using intercepts, and then using slope and y-intercept. And that's the 3 different ways if you want to go watch those and compare them. All right, so let's get started with this. So to graph with the slope and y-intercept, first thing we have to do is identify the slope. So that's going to be -2/3, and identify the y-intercept. Okay? So when I wrote the slope down here, you may have noticed something. Okay? So in this problem, the negative is out front, right? It's in front of the fraction. But when I wrote the slope, I put the negative sign up there in the numerator. And you might be wondering, well, why did you do that? Okay? I'm going to explain that in a minute. But for right now, what I want you to know is whenever you're graphing using the y-intercept and the slope, whenever you're graphing using that, and there's a negative in front of your slope, put the negative either in the numerator or in the denominator. Makes no difference which one, just put it in one or the other. I'm going to explain that in a minute. What I typically do, I usually just always throw the negative up there with the numerator. Don't know why, that's just what I do. Okay? All right, so now let's graph this thing. Let's see if I can draw this thing half decent. All right, so what we want to do is we want to plot the y-intercept. So there's the point 0, 1. And remember what I told you earlier. Slope, rise over run. Okay? So the numerator of the slope, that tells us how we move up and down on the y-axis. The denominator tells us how we move left and right on the x-axis. And let me label these. That's x and that's your y-axis. All right. So if I start at my point, now I'm going to look at the numerator. That's -2. That tells me how I move up and down. Well, since it's -2, I'm going to move down 2 units. Okay, so I went down 1, 2. And then I have a +3. That's the run, tells me how I move left and right. So that means I'm going to move 3 units to the right. And here is my line. Okay? I know it's not straight. It's good enough. All right. So the next thing I want you to look at is, remember, I told you you could put the negative either in the numerator or the denominator, that it didn't matter. Okay? So let's suppose we took this thing down to the denominator, put the negative down to the denominator. So let's look at that. So now we got 2 in the numerator, so we're going to go up 2, -3 in the denominator, so I'm going to go to the left 3 units. And there's my point. Okay? I know it's not lining up perfect. That's because the tick marks these marks aren't evenly spaced. But what I'm getting at is wherever you put the negative, your point's either going to be over here or it's going to be over here. Okay? By doing this, I'm just showing you it doesn't matter where you put it. The negative. You just got to put it one or the other, the numerator or the denominator. Just pick one. Now, you don't have to do both. Okay? You don't have to do both unless the directions or your teacher tells you to. Okay? But you don't have to do both. Just do this, plot that point, draw your line, you're done. You don't have to do that. Or use this, put your point, draw your line, and you don't have to do that one. Okay? All right, now let's look at this one. Well, this is going to be the same thing. Let's get our slope. So our slope is 3. But look how I'm writing it. I'm writing it 3 over 1 because I want to see the rise. I want to see the run. Okay? And then my y-intercept, 0, -1. So now, let's graph it. So let's plot our y-intercept, 0, -1. And then I've got the rise. That's going to be 1, 2, 3. The run is 1. And so there's my point. And so now I can draw my line. All right. So I hope that made sense. Okay. I hope that made sense. All right. Let's look at this. Okay. So now we're getting to parallel and perpendicular lines. So two non-vertical lines in the coordinate plane are parallel if and only if their slopes are equal. That makes sense. We'll talk about that in just a minute. And two lines with slopes m1 and m2 are perpendicular if and only if m1 times m2 equals -1. Okay, they're perpendicular. Now that one don't make as much sense as the first one, does it? So let's just look here. Let's come down here. So parallel lines, we know those are lines that don't intersect, right? So you can see that the angle of them here is the same. Their slope is the same. Okay? The rise over run is the same. They're parallel. Their slopes are the same. Perpendicular lines, do we know what perpendicular lines are? That's lines like that. They intersect. Do you remember what that means? That means they intersect at a 90-degree angle. That's perpendicular lines. So what this is telling me, that they're perpendicular if and only if I can multiply the two slopes together and I get -1 as an answer. That's when they're perpendicular. Well, there's an easier way to think about it. Two lines are perpendicular if their slopes are negative reciprocals of each other. Slopes are negative reciprocals of each other. So in other words, if I have a line that has a slope of 2/3, what would be the slope of the line perpendicular to this one? -3/2, negative reciprocals. You flip it and change the sign. What if it was 7? What would be the slope of the line perpendicular? That's right, -1/7. What if it was, I don't know, -3? That would be what? 1/3. All right. So with that in mind, let's go ahead and work these next two problems. Find the equation of the line through 1, -4 that is parallel to y equals 3x plus 2. All right. So what did it say? Find the equation of the line. Do you remember what I told you back at the beginning of the video? Find the equation of the line. First thing to pop into your head, I need the slope and I need the y-intercept. I'm sorry. I need the slope and I need a point on the line. All right. Well, I've got the point. Do I have the slope? Well, they don't come out and say it, but they tell us that our line is parallel to this one. So that means the slope of our line is the same as the slope of this line right here. So the slope of our line would be what? Well, if it's the same as this slope, then the slope of our line is 3. And so now we have the slope of our line. We have a point on the line. So now I can use the y minus y1 equals m times x minus x1. Remember what I've been telling you in all the videos, that there's formulas. Anytime you got to use a formula, write it down. Now let's just plug everything in. So I've got y minus y1, so that's y minus negative 4, which is y plus 4, equals 3 times x minus x1, that's 1. And then I solve. Y plus 4 equals 3x minus 3. Whoop, getting ahead of myself there. Subtract 4 to both sides, so I get y equals 3x minus 7. And that's your answer. Okay? Assuming I didn't make a careless mistake, which I don't think I did. So let's go and look at the next example. Find the equation of the line perpendicular to the line 3x minus 4y equals 8 and containing the point negative 2, 1. All right. So once again, that right there, that tells you, okay, I need the slope and I need a point on the line. Do I have a point on the line? Yes, I do. The negative 2, 1. Do I have the slope? Well, they don't come out and tell me the slope, but they tell me that the slope of our line is perpendicular. They tell us that our line is perpendicular to this one. So that means the slope of our line is the negative reciprocal of the slope of this line. So let's find the slope of this line here. So I've got 3x minus 4y equals 8. So I need to solve for y. So subtract 3x. So I've got negative 4y equals negative 3x plus 8. And then divide everything by negative 4. And so I get y equals 3/4 x plus, nope, not plus, minus 2. Okay? So that's the slope of this line. So that means our slope, the slope of our line, is what? Negative 4/3. It's the negative reciprocal of the slope of this line, which is 3/4, because our line is perpendicular to this one. Okay? So now I have the slope, I have a point, so y minus y1 equals m times x minus x1. So y minus 1 equals negative 4/3 times x plus 2. So y minus 1 is negative 4/3 x minus 8/3. And then I'm going to add 1 to both sides. So I get y equals negative 4/3 x minus, and I believe that's 5/3. Yep. And so there's your equation. Okay. Okay, so now let's talk about standard form. There might be some times where you use standard form, but the majority of the time, whenever you're writing the equation of your line, more than likely you're going to be putting it in slope-intercept form. You're going to be solving whatever equation you have. You'll solve it for y, just like we've been doing in all these problems here. Okay, so when you're working problems and they're asking you to find the equation of a line, in the directions it may say right answers in slope-intercept form. Or it might say right answers in standard form. Okay? And this is standard form. The x and y is on one side equal to a constant term. Okay? So standard form, let me just show you how to rewrite something in standard form. So let's suppose we have y equals, say, 4/3 x plus, I don't know, 2 plus 2/3. Let's say that's what we have. And I want to write this in standard form. So what this is telling me is I need to get the x and y on one side. So I'm just going to subtract 4/3 x to both sides. And so that is going to leave me with negative 4/3 x plus y equals 2/3. Okay? Now, about standard form. Whenever you're looking to write your equation in standard form, you want integers for a, b, and c. You want those to be integers. You don't want fractions. And you want the number, the coefficient of x, the number in front of x, you want that to be positive. Okay? So you want a, b, and c to be integers and coefficient of x to be positive. So we got to get rid of the fractions. Okay? Well, we know how to do that. So to get rid of the fractions, I just multiply everything through by the common denominator. Okay? And that's going to get rid of the fractions. But it's also going to leave a negative in front of x, and we want that to be positive. So instead of multiplying by 3, I'm going to multiply by negative 3, because we know a negative times a negative is going to give us a positive. And so now we're going to have what? 4x, because the 3's cancel, and negative times a negative is positive, minus 3y equals, and then that's going to be what? Negative 2. And there's your standard form. Okay? Okay, so what about this one? So it says, given a rhombus with vertices 0, 0, 5, 0, 3, 4, and 8, 4, prove that the diagonals of this rhombus are perpendicular. Okay, so let's go ahead and let's plot the points first. Okay, let's plot these points. So I've got, let's see. So I've got 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. So let's plot the points 0, 0. And then I've got 5, 0. 1, 2, 3, 4, 5, 0. And then I've got 3, 4. 1, 2, 3. And then that goes up here to 4. And then I've got 8, 4. So that'd be right there. And here's my rhombus. Right here. And then what they're doing is they're saying, okay, we've got these diagonals here. Okay. A lot of times in math, if you just draw it out, it's a lot easier to see. Okay. So this is, let's see, this is the point 8, 4. This is the point 3, 4. This is the point 0, 0. And this is the point 5, 0. And what we want to do is we want to prove that this line and this line are perpendicular. So how do we do that? Well, find the slope of the lines. See if they're negative reciprocals of each other. Or once we find the slopes, we can multiply them together. And remember what it said, if you multiply the points together, okay, if you multiply if you multiply the slopes together, you should get -1. All right? So let's find, I don't know, let's call this, I guess we can call this L1, or I'll tell you what, how about we call this line A, we call this line B. So we've got the slope. I'm going to put a subscript to let me know that's the slope of A. All right. So remember, that's y2 minus y1 over x2 minus x1. So that's going to be, and I'm just going to call this the point x2, y2, and this the point x1, y1. So y2 minus y1 over x2 minus x1 is 4 over 8, which is 1/2. Okay. Now let's find the slope of B, of this line B. So now let's just call this, we'll call this one down here x1, y1, and this one x2, y2. So that's y2 minus y1 over x2 minus x1. So we've got y2, which is 4, minus y1, which is 0, over x2 minus x1. So that's 4 over -2, which is -2. And you can see right off the bat, these are negative reciprocals, but we can go further and show it. So the slope of A times the slope of B, which is 1/2 times -2 equals -1. And that proves that those two diagonals are perpendicular. All right, let's look at another one. How many more we got? We got 2 more examples. All right, just hang in there. I mean, if you've watched this far, you might as well watch the rest of it. All right, so from ABC Wireless, the monthly cost for a cell phone with 100 minutes per month is $35, or you can get 200 minutes per month for $45. Okay, and so what we've done, here's your minutes down here. This represents the minutes. So 100 minutes is $35. There's a point there. That's the point 135. And then 200 minutes for $45. So if we go over to 200, that goes up to 45. This is the cost. This is the time. All right. And what do they want to know? Find the formula for C. So what they mean by that, find the formula for C, they're saying find the equation of this line here. And then what is the cost for 400 minutes per month? All right, so let's just work that here. So part A. All right. We need the equation of the line. Well, we've got points on the line, don't we? You see the points? Well, we need the slope now. All right. So the slope is going to be what? C2 minus C1 over T2 minus T1. Okay. Don't freak out because the letters have changed. This is the T and the C axis. This is like your X, Y. So all I'm doing, I'm just going to call this T1, C1, T2, C2. See? X, Y, X, Y. See, this is like X and this is like your Y. All right. And so that is going to be, let's see, C2, that is 45 minus 35 over 200 minus 100. And I'm going to just go ahead and write down what this is. This is 1/10. Okay. You can do that in your head. I just wrote down the 1/10 because I've run out of room. So now let's find the equation of the line. So now let's write down the point-slope form. Okay, so that's going to be what? C, right? C minus C1 equals M times T minus T1. See that? Remember, C is like your Y and T is like your X. Y minus Y1 equals M times X minus X1. That's all it is. So remember, we can use either point we want to plug in for T1 and C1. We'll use this one down here since they're smaller. And so I get C minus 35 equals 1/10 times T minus 100. All right. And so that's C minus 35 equals 1/10 T minus, and I think is that 10? Okay, so then I add 35 to both sides, so C is equal to 1/10 T, and then look, if I add 35 to both sides, I get plus 25. And there's the answer to part A. So now for part B, it says, what is the cost for 400 minutes per month? So I want to know the cost. So that's just going to be C is equal to 1/10. 400 minutes, that's T. So I want to know what is C when T is 400 plus 25. And that would be what? That's 40, right? 400 divided by 10 is 40 plus 25. And that would be $65. Okay. All right, last problem right here. All right, so let's take a look at this. So it says a manager for a country market will spend a total of $80 on apples at 25 cents each and pears at 50 cents each. Okay, so a manager for a country market will spend a total of $80 on apples and pears. The apples are 25 cents each, the pears are 50 cents each. Write the number of apples she can buy as a linear function of the number of pears. Find the slope and intercept and interpret your answer. All right, so well, let's come up with the equation of a line. So for this, we'll actually have to, this is going to be a standard form. So if I come up here and I say let A equal apples, okay? A equal the number of apples, and let P equal the number of pears, then the cost of an apple times the number of apples plus the cost of a pear, which is 50 cents, times the number of pears is equal to $80. All right. And what they're wanting us to do, write the number of apples she can buy as a linear function of the number of pears. So they're wanting us to solve for A. That's all that means, is solve for A. So if I subtract 0.5p to both sides, I get 0.25a equals negative 0.5p plus 80. So then I divide everything by 0.25. And you would have to use your calculator here. So I would get A equals, And that is going to be what? Negative 2p plus 320. And so that's what they're wanting for the first part. And then it says find the slope and interpret your answer. Well, the slope, that's this number here. That's negative 2. There's the slope. Okay. All right. So interpret your answers. So we wrote it as a equals negative 2p plus 320. That gives us that expresses the number of apples as a function of the number of pears. And we notice that the slope is negative 2. So what does that do? That causes the number of apples to decrease by 2 when p is increased by 1. And that's keeping the total cost at $80. All right. And this kind of makes sense though, don't it? Because the cost of a pear is twice the cost of an apple. And that gives us the slope of negative 2. Okay. So that the explanation I gave, I don't know if you understood it. I hope you did. But yeah, I mean, that's it. So you can see, you can do a lot of things. You do applications, graphing. There's a lot you can do. Slope, y-intercept, finding equations of lines. So I hope you enjoyed the video. I hope you hung around for the whole thing. Check out my other videos. Give me a like, share, and subscribe. And thanks